Welcome to Lab Workshop 2 on regression. So we're going to open the data file that's in your lab tab. And in this data file, we'll enable editing. We see we have some data about mutual funds. We've got 25 different mutual funds, and we've got information about the type of fund, the years of experience of the fund manager, and the annual return of the fund. So we would like to be able to use this data to predict annual return if we know something about the funds. And we think that years of experience may be something that would be useful as far as predicting the annual return of a fund. So the first thing we might do is actually see if there seems to be a relationship between the years of experience and the annual return. So to do that, we can do a scatter plot. So I will highlight experience and returns, including the labels there. I'll go to Insert, and I will choose a scatter plot, just a simple scatter plot. And this is what I get. Now I should work with my chart here. I'm going to put a title. So this is experience and annual returns. My x-axis, I'm going to pick a layout that gives me axis labels. My x-axis is annual returns. Or my y-axis, and my x-axis is years of experience. And it certainly looks like there is a relationship here. As the years of experience goes up, so does the annual return. Now we can get Excel to fit a line to this data and to give us some more information. So if I right-click on one of the dots, one of my right-click menus is to add a trend line. And by default, it's going to add a linear trend line, so that's fine. At the bottom, I have some options here. I want it to display the equation on the chart, and I want it to display the R-squared value on the chart. And so there's my fitted line, and I can move the equation and the R-squared so I can read it more easily. So my equation, the equation of my line is y equals 0.0284x plus 0.0426. So 0.0426 is my y-intercept, 0.0284 is the slope of the line. And it tells me I have a coefficient of determination, or the R-squared, of 0.8918. So we know that we can interpret that to mean that 89% of all of the variation in annual returns is explained by our model using years of experience. So that would be very, very good. That's probably unrealistically high for a model of this type. We could also get the equation of the line using an Excel function called the linest function. And the linest function is going to do the calculations to give us a b value and an a value. And it's an array function. We heard about these the last lecture. This is your first chance to use one. So for an array function, we want it to calculate values for more than one cell. And in this case, we know that they're using two very different formulas to calculate b and to calculate a. Those calculation formulas we saw in the lecture. So for an array function, I select all of the cells that I want calculations performed for, and then I say equals, start to type line S for line estimate, and the first thing it wants to know is my known y's. So my y value is, my dependent variable is my annual returns, so I'll show it my annual returns. It then wants a comma, and then the known x's. So x, my independent variable, is years of experience. We'll show it that data. And the remaining items there are options, which I don't want. So to finish off an array function, I don't press enter. What I have to do is hold down the control key and the shift key and then press enter. And so it's given me the values, and those are the same values that we got when we asked for it as part of the chart. So I've got my line estimate. Now I'm going to go through some basics here first before we get into the regression tool in Excel. We can calculate the predicted value according to our model. By using another array function. So this is a function called trend. So I want it to calculate a predicted value for all of these cells. So I have to select them all. Then I say equals trend. And the trend function again wants to know my known y's, or my values for the dependent variable, comma, known x's, my values for my independent variable. And then again, I hold down Control, Shift, and Enter. So for this first fund, the manager has 4 years of experience. If I plug that value of X into my formula, the predicted value for the return for that fund would be 15.6%. And I've got predicted values for all of the remaining funds. That means that my error or residual which is also called the error, is going to be equal to the actual return of that fund minus the predicted value. And I can calculate residuals for each of those by copying that formula down. So now I've got all my residuals or my error terms. We said that to make sure that we're not violating any of the assumptions of the regression model, we should examine certain characteristics of our residuals, and we do that by plotting our residuals against our independent variable. So I'm going to select my independent variable, again my years of experience, and then because I want non-adjacent columns, I can hold down the Control key and then select my residual column. I can then insert another scatter plot, which is my residual plot. With this, my y-axis is the residual or error. My x-axis is years of experience. And what I'm looking for here is a nice random pattern. No particular patterns emerging as the years of experience gets greater. We don't see any great changes in the variance. It looks like the residuals are, the expected value would be 0. And if we have this nice random pattern, we can assume they're normally distributed. So that was sort of going back to basics to do all of this. Now we'll see how the regression tool in Excel will do this for us. So I'm going to go to my data tab at the top, my data analysis tool pack, and I will pick out the regression tool. So with the regression tool, it needs to know the Y range. When I'm doing the regression tool, I always want to include labels. So I'm going to include the second row here, which has a meaningful label. It says return, so I'll know what that is. And then my X range, I'm going to include the word experience, and then the data. And I'll check the box that says I did include labels. In this case, since I've done some other work on this sheet, I'm going to ask for it in a new worksheet, for the results to go to a new worksheet. So this will be my regression analysis sheet. And for my options down at the bottom, I'm going to ask for residuals and residual plots. And I will say OK. And I can see down at the bottom here, now I have a worksheet called Regression Analysis. I've got my residual plot for experience, which looks just like the plot that we created on the previous sheet. To look at my summary output, a quick trick for adjusting the column width for a number of columns is I select all of the columns, I take my cursor over to the very end until it changes, the cursor symbol changes to that bar with two little arrows, and then I double click, and that will adjust all of the columns to fit the data that's in each column. So my summary output, I can see I've got my R squared as 89% again, 0.8918. I've got 25 observations. My hypothesis test, my first hypothesis test in simple regression is that the R squared could be 0. I did a test using the F test statistic. I have a very large value of F, which means I have a very small significance F. So since that significance F is smaller than my chosen level of significance, if I'm using 0.05, it's much smaller than that. So I am very sure that that R squared value is not 0. In the bottom part, I've got the coefficients. In the coefficients column, I've got my intercept and the coefficient for experience, which is the slope of the line. And my second hypothesis test is that that coefficient might really be 0. But because this is from sample data, maybe I just had an oddball sample of some sort, and the coefficient is really 0. So my test there, my test statistic is the t statistic, and my p-value tells me the probability of getting a t statistic greater than that, and that again is a very small number, smaller than my level of significance, so I can be confident that that coefficient is not 0. So it looks like we have a legitimate statistically significant model. So the question on the workshop instructions says, what's your estimate of the annual return of a fund where the fund manager had 7 years of experience? So where the fund manager has 7 years experience, our model predicts that the annual return of the fund will be. So how do I calculate that? I have to use my formula, and my formula says that the that y, the annual return, will be equal to my intercept, so I can point to where my intercept is, plus my coefficient times my value of x. So in this case, x is the years of experience. This manager has 7 years of experience, so it'll be times 7. And that's equal to 0.24. I can go and convert that back to a percentage. So our model predicts an annual return of the fund of 24.12%. So that's simple regression with this example. I also can do multiple regression because I do have other information here. I know the type of fund, whether it's a stock fund or a bond fund, and that could also be useful in predicting returns. But stocks and bonds is a qualitative variable, right? It's not a numerical variable, it's a categorical variable. And so we need to create a dummy variable. So I'm going to insert a column here. This will be called type of fund as well. And then every time I see a stock, that it's a stock fund, I'll put a 1. Every time I see bonds, I'll put a 0. So now I've got my dummy variables. I can go to my tool pack again, choose my regression tool. I've changed my columns here, so I'll have to re-input my Y range is my returns. My X is now both the type of fund and the years of experience. I include labels. My output range, I'll choose an output range here. I'll click the button and then click in the box and say I want my output to start here. And I'll ask for residuals and residual plots again. So here is my output. Over here I have my experience residual plot again. I also have a residual plot for the type of fund. And the values were just 0 or 1. So that's where the values of the residuals are all collected. But there's no red flags there. So I'll go back and look at my summary output. So my R squared has gone up to 0.95, or almost 96% of all of the variation in annual returns is explained by our multiple regression model. I go down to my F test. So I'm testing, my hypothesis is that R squared might be 0. I have a very, very small value for significant F, so I can reject that hypothesis. So I know there's a good regression model somewhere, but it doesn't tell me anything about the particular variables, each of the independent variables. For that, I have to go down to the bottom section here. I've got the coefficients of my regression model here, the intercept, and then a coefficient for fund and a coefficient for experience. I look at my p-values for fund. It's a very small number, again, so I am very confident that fund is having a significant, statistically significant effect on this model. And I have a small p-value for experience, so it again is having a statistically significant effect on the model. So everything looks good. My last question is, what is your estimate of the annual return of a stock fund where the fund manager had 7 years of experience? So for a fund where the a stock fund where the manager has 7 years of experience. Our model predicts a return of, so again I have to use my regression equation here. That's going to be equal to the intercept plus the coefficient for fund times my value for fund. So my values for fund were either 1 or 0. This is a stock fund, so my value for fund would be 1, plus the coefficient for experience times 7, because this manager has 7 years of experience. I say enter, so it tells me that the predicted return for this fund is 26.8%. That's what the model will predict for the annual return for this fund.